that much. I mean, I think we only had 2 classes on vectors in physics, whereas with the maths we have to study it in more detail. So there's like, I don't know, it must be about 7 classes of vectors to do in the maths. But the first class is really, really easy, and because you've already done vectors in physics, it's not going to challenge you much. So let me just open it here. Do you remember the definition of a vector from physics? It was like something we did in week number 1.
Magnitude, direction.
That's it, yeah. And we represent a vector by using a arrow on the page. So like a vector is a quantity, is an object, now let's be more technical, is a mathematical object that has a magnitude and a direction, and is represented by an arrow. And this part down the bottom, do you remember what it's called? This part and this part? I think I did say it in physics, but we haven't really needed to say much about it. This one is called the head. Tail, not legs. The head and the tail then, yeah. So this could be, for example, something like vector x. And we represent the vector variable by putting a little arrow on the top, or in the exam or in your book it might be the variable in bold font. Some books put a line on the top, a twiddle on the top, line on the bottom, twiddle on the bottom. Have I seen any others? No, I think they're the main ones then. Yeah. I kind of use these 2 only, which is the 2 that they use in the exam anyways. But I'm just saying, if you were looking at a website or a book, it's possible that you might see these used as well. Yeah? Okay. Can I scroll down?
Yes.
Yeah. Mirror? No? I don't think so. I think they were possibly. Well. Couldn't quite make it on time, no? So what happened?
Traffic.
You have a car. So it means you left your house too late.
45. And we got it at 1.
You would have been quicker walking. Would you drive from Rathmines? I will not try to understand. Okay, let's have a look at some pictures here. Yeah, we didn't do this, or did we? I don't remember actually. Did we do the parallelogram law in physics? How did we add vectors together in physics? Did we use the vector triangle?
Yeah.
The triangle, yeah. If you want to write this down, there's another way to add vectors together which is what they want in the maths syllabus. In the physics syllabus, they wanted you to use the triangle law. In the maths one, they want you to use the parallelogram law. So if you can just write this name down, please. Parallelogram law. You got that, Jeff? You can scroll down? Yeah? Okay, so how does the parallelogram law work? You have two vectors, let's say A and let's say B. So the first thing you do is you make sure that their tails are together. So with vectors, you know you're allowed to move them as long as you don't change the size of it or the direction. So I could like draw this one, let's say here, and that's A. And I can draw this one here, and that's B. So I can just move them around the page. Because like we said in physics, vector is only its length and the direction. So as long as you don't change those, your vector is okay. Yeah. Now, how does the parallelogram law work? What you do is you start at the head of A and draw a line, and this line needs to be parallel to B. Parallel to B. And then here, I'll do it in red, we draw another line, and this one needs to be parallel to A. And then the answer for A plus B is the vector from where they meet here on the diagram to where the two parallel lines meet here. This is vector A plus B. And this is the parallelogram law. Because in maths the name of this shape is a parallelogram, which is the shape that we get here. And if you're wondering, you do get the same answer if you use the triangle law from physics as well. Okay? So, if you can draw this, this is the parallelogram law. How's my battery doing? Oh, it's okay. Got that yet? Easy peasy stuff, yeah. Can I use, no. Adnan, you drew this?
Yes.
You did, where? They're tiny, okay. You got this, Iyad, yeah? Mushrif? Yeah, okay. So, for the following, we'll say x is a vector. Whoops. Y is a vector. Mu is a scalar, so that's a real number that's not zero. And lambda, we'll say, is a real number which is not zero as well. Okay, so tell me which of the following can we do? So can we multiply, you remember this from physics I hope, can we multiply a scalar by a vector? Is that allowed? Yes or no? Yes. The answer is it a vector or is it a scalar? It's a vector. And what's special about it is if this is vector x, then vector mu x will be mu times bigger. So if mu was 2, it'd be 2 times bigger. What happens when you multiply a vector by -1? It's still a vector. It flips around, yeah. So the x is here, and the minus x is here. We've seen how to add vectors. That's also a vector, and that's the law we just did, the parallelogram law. Is it possible to subtract vectors? What do you think? Yep, so it's just x plus minus y. Yep, so that's fine. And of course you could multiply each vector by a scalar and then add them together as well. That's fine. You get a vector as well. Get a vector as well. And what did I tell you is not possible in vectors from physics? What can we not do with vectors? Can't divide them, yeah. So this is a big no. Vector x divided by vector y is something we cannot do. And what else? Anything else?
Multiply.
Yeah, so in physics class we can't multiply vectors together, but in maths class we can, and this is something we'll do later. But it is actually okay to do. It's a special lesson which we'll have later. So for this lesson it'll just be the usual 1 to 5 rules that we can do. Okay, so I just think it's a good reminder if you can write these down then, but you all seem to remember them, so that's good. Continue? Yeah? Great. Okay, let me just see what else we have for the first lesson. So, I don't think there's... Now, the only other thing which I haven't said is, which you, again you know from physics. So if this is the vector, we'll call it vector x, for example. Then what is the magnitude of x on the diagram? What represents its magnitude? Its length, yeah. So from here to here is the magnitude of x, which is the length. Yeah? And this symbol, this is the direction. And what represents the direction? On the what exactly?
The head of the...
Not quite the head, the angle. Yeah, where it's pointing. So this here is the direction. Yeah. Okay, so Well, do you need to write that down actually? Yeah.
You won't use any property.
No? How come?
Then it's even,
Really? You didn't tell me about this.
you just,
Dennis emailed you saying there's no ESAP?
yeah, because we will be having MMI session and talking about.
Yeah. So,
I'm just finishing 12.
oh, nice.
Mm-hmm.
So, what class do you have at 11 then?
Chemistry.
Finish at 1 again.
Yeah, it's one of them.
Oh, double physics,
Double chemistry.
double chemistry. That's alright, isn't it?
Yeah.
I finish at 6.
Why did you finish at 6?
Have support.
That's funny.
Silver.
So what are you going to do for 5 hours, 4 hours?
None.
Adnan, hang out with Adnan.
Yes.
Okay, go back to the worksheet, yeah. So the good news is, for your first class back after your holiday, you have a very easy lesson of drawing pictures. So here, I drew, whatever, 1, 2, 3, 4, 5, 6, 9 vectors, and I asked you to practice the parallelogram law by adding them together. So the first one is to add A and B. You see, there's A and B there, and then D and E, C and F, and so on. So the first one is just add them. Then here I want you to practice multiplying by a scalar. It's the same letters as the first one, A, B, C, D, E, F, G. So for the first one you have to draw 2A. So you can see there's A, so 2A, just draw it twice as long. 3, I just make it a little bit more complicated by multiplying and then adding together. And then 4, you don't have to do 4, because I don't think you have, do you have a protractor? A protractor is used to measure the angle, you know, the half circle.
Yeah.
D.
Yeah, no, I didn't think so. So you don't have to worry about number 4. So, it's, take out your best colouring pencil and draw some vectors for me. I can leave this up here if you want to. Yeah, actually, you know what? Maybe what you should do first is draw these in your copybook so you can use them later. So if you can draw these. Now, it doesn't have to be perfect, but, you know, get the right idea. So, for example, A and B, they're both at angles and they're both about the same length. You drew them? Okay, so if you want to open up the questions on your phone then, because I think it's easier to see the vectors on the board here. I don't want to spend too much time on this because you've done it in physics, so we'll just give it 10 minutes and then we'll start the next topic on vectors. Which is Dude, the next lesson wasn't vectors, it was trigonometry. I suppose it doesn't matter what order we go in. No, I'm trying to think, do we need vectors for trigonometry for vectors, and we don't. That's okay. I think you prefer to start with something easy today anyways.
Yeah.
Never trust Miss Sharif. That's what I've learned.